Alright, the next one, they ask us to find the sum, and if you notice these are infinite geometric series. Infinite because they keep going on forever. So first of all you have to figure out, remember the formula to find the sum of an infinite geometric series. Let me change pens. The formula says the sum is equal to t sub 1 over 1 minus r. So what do you have to multiply 20 by to get 4? Well, divide it by 5 or multiply by 1/5. And does that work to get from here to here? Yep, because 4 times 1/5 is 4/5. 4/5 times 1/5 would be 4 over 25, etc. So I know that r is equal to 1/5, and I know t sub 1 is equal to 20. So using my formula, the sum will be equal to t sub 1, which is 20, over 1 minus 1/5, which is the same thing as 20 divided by, this is like 5 over 5 minus 1 over 5, so it's 4 over 5. Then dividing fractions, easy as pie, flip the bottom and multiply. So 20 times 5 is 100 divided by 4, so it's going to be 25. That's what the sum of that sequence is. Let's do it again for this one. Remember your formula, the sum is equal to t sub 1 over 1 minus r. So what do you multiply 28 by to get it to be 14? I believe it's 1/2, and half of that is 7. So we know r is equal to 1/2, and obviously t sub 1 is 28. So the sum will be equal to t sub 1, which is 28, over 1 minus 1/2, which is 28 divided by 1/2. Dividing fractions, easy as pie, flip the bottom and multiply, and 28 times 2 is 56. So there we find the sum. Alright, the next part, it says find the first 4 terms, and these are the recursive problems. I know they're recursive because they have that t sub n minus 1. So they said find the first 4 terms. Well, I already know the first term is 1, so the second term would be, you just let n be 2. So this is your formula right here. Okay? So t sub 2 is equal to, t sub 2 minus 1 would be t sub 1 minus 4. So t sub 1 is 1, and 1 minus 4 is negative 3. To find t sub 3, I use 3 in the formula, so I would say t sub 3 minus 1 would be t sub 2 minus 4, and I just figured out that t sub 2 is negative 3, so negative 3 minus 4 is negative 7. To find t sub 4, I just let n be 4, so t sub 4 minus 1 would be t sub 3 minus 4, which t sub 3 we just figured out was negative 7 minus 4, so it's negative 11. So my first 4 terms are 1, negative 3, negative 7, and negative 11. Those are the first 4 terms of the sequence. Let's do it again on this one here. T sub 1 is 5, and t sub n is equal to 2 times t sub n minus 1. So there's my recursion formula. This is how they initialize it. So to figure out t sub 2, I'm going to just scoot this up a little bit so we can see. And this is our problem right here, below here. Alright, so to figure out t sub 2, we would say it's going to be n is 2, so it's 2 times t sub 2 minus 1 is 1, or 2 times t sub 1, which is 5, so it's going to be 10. T sub 3 will be equal to 2 times t sub 3 minus 1, or t sub 2, which will be 2 times what we just found, which was 2 times 10, so it'll be 20. And then t sub 4 will be equal to 2 times 4 minus 1 is 3, and so that would be 2 times t sub 3, which is 20, and so 2 times 20 is 40. So the first 4 terms would be 5, 10, 20, and 40. It looks like they'd get from term to term, they just multiply by 2. There we go. So we've got sums of infinite series and recursive definitions. Hopefully we can see that.